Everybody asks me about TIG welding thin sheet metal. A lot of people have a lot of trouble with this, and I just want to go over the key things that you need to know to make this as easy of a process as possible.
Okay, we're gonna get into sheet metal now.
Everybody asks me about TIG welding thin sheet metal. This is something that is not as hard as you're making it out to be, I promise. A lot of people have a lot of trouble with this, and I just want to go over the key things that you need to know to make this as easy of a process as possible so that you're gonna want to do it on sheet metal. If you're MIG welding a panel together and you're butt welding two pieces and you have a little bit of a gap, that's probably okay, because your MIG weld ends up depositing like a little ball of metal onto it that's kind of big and it can fill a gap. You just don't want to fill a gap in sheet metal with TIG welder. One of the things, and the very first thing that has to happen, is that those pieces fit tight, meaning that if you're putting a patch panel on, you're gonna wanna fit that patch panel as perfect as you can. Take note of the thickness of material. Like if you're overlapping it and then cutting a piece out, you'll have to, subtract the thickness of a piece of material so that it fits all the way in. Like you have to be quite accurate with the way your panel fits so that when you scribe the panel, I would use a Sharpie or layout die so that you can cover the area that you are going to be marking with the layout die or Sharpie, and then use a sharpened tungsten, works great as a scribe, to actually literally scribe out that material. You can then take a file and you could file the corners a bit, you can file these pieces. You want that piece to fit as perfect as you can. And the more time you spend on that, the better time you're gonna have on the welding. And the reason why I'm really talking to you about this is because that's how important it is if you want to weld thin sheet metal. The more you do that, you will get better at it and it'll become less of a big deal. Once you've got a joint that is fitting super tight, is the way that you tack that piece in. If I tack this piece right now on this end, and then try to fit the middle, I've already screwed it up. Because if I tack on this end, and one panel is slightly above and one slightly below, by the time I tack those all together, it's gonna kind of bunch up and one's gonna be too low and one's gonna be too high. So what you must do when you're tacking is you start at one place and you just work from there. That's why all your fitting has to be so good. If you can trust your fitting, like it only fits this one way because it's so tight of a fit, then you know that if you can get that panel in there, it's going to fit that way. During that process of you tacking, something else is going to happen. You're going to experience tack shrinkage. So what you need to do then is you tack, and if it tightens up to the point where your panels are pressing together too much or they want to overlap, you have to take a hammer and a dolly underneath your tack, give it a whack, two whacks, like just hit just the tack enough to stretch the tack out a little bit to allow your panel to open back up and relax. I'm tacking probably every inch or so. I don't want to see any tack further than 1/2 inch to a 3/4 of an inch from another tack. Because when you are welding like that, you'll actually be able to see it. The panel wants to move a little bit. You don't want your panel to misalign because of the weld that's coming up on it and the warping that's already happening. Okay, so I'm gonna start tacking now. What I'm gonna use is, I've got a 1/16 tungsten. I'm gonna use 040 filler rod. There's another kind of trick of the trade, is that you do have to use a very thin filler. The advantage of using a thin filler rod when you're doing thin material is that now, like I was talking about before, you're not adding more heat than you need. So what I'm doing is I'm watching my puddle, because you can see it. I'm gonna be in the direction of travel as I'm welding, and I'm watching the puddle, and if the puddle looks like it drops a little bit, I'll add a little bit of filler. I'm gonna fusion tack this. It's getting a bit tight. Now we've got, a bit more movement on it. All right, we are looking pretty good. Another way to check that is you can take a piece of wire here, and just kind of like roll it along your weld. So like I said, we start off with about 1 inch apart, but now we want to tighten up our tacks. I'm going to probably split all of these, maybe even 2 in that one. Your heat and your amperage are not always correlated. If I want to have very little heat in this panel, for you to go quick rather than slow, you need more amperage. But more amperage makes you think like it's going to be hotter. It's not. It technically is hotter, but your panel isn't going to be hotter because you're going to move quicker. The other thing I'll say is that if you do decide to change your cup to those larger cups like you've seen people using, I use them as well, you can turn up your gas flow at the same time. Does 2 things, allows your stick out of your tungsten to be longer so that you can see better, get into smaller places, but that extra gas flow that is needed to allow you to have that longer tungsten stick out is also going to help cool your panel. Think about it. When we're tacking with MIG, I'm using an air blower to cool. Well, the argon that's coming out of here is more expensive air. It's just cooling the material.
I'm dropping a dab of filler every 1/2 to 3/4 of an inch. We're not looking for the most pretty welds like we do with thicker material. We are just looking to get it fused and enough.
You can see exactly where I've added filler. I added filler there, I added filler there, I added filler there, I added filler there. Otherwise, it's just a very flat weld. I'm very happy with the weld itself. This little spot where you see my heat change, that's the stop start. No matter what you do, this is warping it. You can't ask me, how do I do it without warping? Because it doesn't happen. We would have to hammer this out. But because it's such an even and consistent weld and consistent heat, it shouldn't be that hard to planish that out.